Hello and welcome to my presentation for Python for Data Science, CSCI E29 at Harvard University. My name is Anoop Mankar and this is my presentation on real estate investing. This is the staff for E29 in spring of 2018. So the idea here is that real estate investing is very time consuming. You have to go out to the field um, and assess values of house based on a ton of quantitative factors like the location and the general sense of the house and the layout and things like that. Um, if the the goal of this model is to create a filter, which basically takes all the houses on the market, data on all those things, and creates a prediction of what the list price should be, and compare that to the actual list price, and get a list, basically a short list or a ranking of which are likely to be under market and which are likely to be which are likely to be priced under what they actually should be priced at and which are overpriced, basically. So here's some required libraries and files, and let's get into the model. So a lot of this project was cleaning and formatting of my data. Specifically, there was these categorical variables, which I needed to convert to dummy variables. And as you can see here, this building type um, could actually have multiple types. So converting that into multiple flags basically was a little bit of hassle. You can look into the code here if you need any further input on that. So you can take a look at all this data. Um, I in the end I did get all the categorical dummy variables out, and it ended up being around 27 features and the list price here, which is the thing that we're trying to predict. Um, Here I started the data exploration. So here's, you can see with the numeric fields, there's some general positive linear relationships here, but not super strong. And yeah, we'll get into a little bit more the predictive power of these features. I did some more work here on cleaning the data. Getting rid of some dummy data, some bad data, I mean, some typos, things like that. And then I also engineered a few features. Specifically, here's again, specifically I engineered something called total bathrooms, which is a linear combination of full baths and half baths, and spaciousness, which is the square footage of the apartment um, combined with the number of rooms, excuse me, of the house, and divided by the number of rooms. So you can look into how I did that there. Here's some more data on the categorical variables. So as I referenced earlier, those the house type, whether it's bungalow or contemporary, historic, log cabin, mobile home. Here's the distribution of those, and here's some violin plots which describe the distribution of list prices um, based on the building type. So as you can see, there's some trends here. For example, the mobile homes are a lot less expensive than have a lot lower list price than the manufactured than the rest of the houses. And we did similar analysis on the listing type, whether there was a new listing, whether there's a price decrease or price increase. Um, on to the model itself. So I used a linear regression model. I created some functions here to kind of do the heavy lifting for me. The first run of this with all the variables was terrible. So as you can see, the bedrooms were actually negatively correlated with the list price, which doesn't make any sense because you would think that holding other things constant, increasing the number of bedrooms would increase the list price, but that's not what our model said initially. The R squared is pretty bad too. So yeah, it's not great. the goal of this function here is to actually spit out a data frame of upon which we apply the filter, and it actually provides a price gap, a newly calculated feature, which is not feature, but column here, which will tell you the difference between the predicted price and the actual final price here. So here you can see this, the predicted price here is actually 100K less than the actual price. So using this column, you could actually filter down these different houses and kind of guess at which property is the best to start with, basically. That's all assuming that the predictive part of this model actually works, which, as we saw earlier, it doesn't seem great. So let's tweak the actual model itself and see if we can get something better. So here I'm actually doing some feature pruning. I'm getting rid of some of those engineered features and various other features. Um, After getting rid of those features which weren't that effective, the model actually makes a lot more intuitive sense now. For example, bedrooms are actually contributing positively to the list price. The R squared is about the same, and yeah, and so here's the output of that. So here's the data set upon which the filters applied, and you see this price gap, which tells you how above or below the predicted value the actual list price is. Finally, I applied a ridge regression regularization to this to make sure we're not overfitting. This improved the model slightly. Most of the coefficients are the same, and the R squared actually goes up. So this is in the end, the predictiveness of the model itself based on this data isn't great. So I would not be able to rely on this. But the infrastructure, if there was a better way to predict this, maybe with better data or a different model, um, the infrastructure would actually be great and super useful. So it's all about getting out there and finding better data, as it always is. So thank you for everyone. Thank you to everyone who's actually listened to this. And here are some of my references.